that many class periods left. Who's excited? There you go. The people that are excited are the people that's already got all their assignments in and their grades where they want it. The rest of the people, maybe just a little bit of panic moving in. Yeah, the excited folks are the ones that's sitting pretty. Our final is due 2 weeks from today. That's how close we are to the end of the semester. But yeah, there's a lot of people missing some programs, it looks like. And we're adding another program this week. So a lot of programs in programming. Imagine that. So it's not something you want to fall behind on because you got 4 programs to write. That's going to take you some time, some serious time there. Let's look at what it looks like for this week here. Let's see. So if we go to the programming class in Buzz, go to that grade screen to see what all we have this week. All right. So we had the while loops program last week. That's what was due yesterday. I don't know how many of y'all get that turned in. I don't have any programs to grade this morning. This week we have creating functions, which is also a program to write. And then we have the segment 1 exam, which covers everything that we've learned. So our final. So this is our last assignment for the semester. So this we do this next Sunday. The final will be assigned on the 15th, which is Thursday of next week. Thursday of next week is when our final is assigned. So we'll meet in class next Monday. We'll look to see who's missing what. You guys can, in a panic, try to catch up the rest of your programs to get your grade where you want it. And then we'll have the final, which is worth like 250 points or something like that. It's worth more than a program. We've had a lot of 100-point programs, but the final is worth, I think 263 is what it was worth, something like that. So it's pretty substantial. If I go to a what if and look at their grade, so right now I've got 100%. If I take the final and I bomb it, let's say I make a 40, and see how much that would affect my grade. Recalculate. That would drop me to an 85, even though I've had 100 on everything this semester. Let's say I get 100 on this assignment this week. 86. So if I bomb the final, which is worth a lot of points, even though I have 100 on all these 100-point assignments and all these 25-point assignments, it would still drop my grade a lot. All right, so if my grade wasn't 100, it'd probably affect it even more. So writing these programs is how you learn these things and understand these things. When you take the final, oh yeah, I remember how that works. I wrote a program about that. So this is the answer. And I don't think it's all multiple choice either. I think you got to write some pseudocode, and there's one very short program you have to write the code. You have to write the code for one short program on the final exam. So I say you want to do well on that because it can move your grade a lot. But this week we have our last assignment here, the creating functions. So let's look at creating functions. This is kind of cool where we're ending up here. Creating functions lesson. All right. It says organizers unite. So this says packing is the pits. Mashed shoes, wrinkled shirts, balled up socks, every single space in your luggage. Leaves nowhere for your chargers and deodorant. Right? You're going to want to pack those. The problem is you need all of it. So the answer is a little chunking and organizing. So most you have to arrange things in a certain shape and size and spaces that make the most sense. This is going to relate to programming, right? Items you're using together, you can put your toothbrush and toothpaste together, helps you fit more stuff, fill it more quickly. This applies to programming because we're going to be able to describe the purpose of a programmer-defined function. So far, the function we've used every time is main. We define main at the beginning of our program, but we're going to define other functions today. Demonstrate how to divide a program into smaller tasks, how to call a function, identify values passed as parameters to a function. So let's look at our lesson. It's just a couple of pages. So let's talk about the main function, right? The main function, we define that at the beginning, the one that opens each program. And then we put all the stuff in the function that we want the program to do. So it's basically a long list of instructions that you've broken in chunks of code. So the math module and the Turtle Graphics module both include libraries of functions. They include a chunk larger work in the simple code. We use the print function, the power function, the forward function, the left function, all programmer defined functions that contain code that makes them work. All you have to do is just call that function by typing it. So Python goes and gets that. But we're going to write our own functions now. So let's roll over the parts of code to see how to define a new function. If we roll over here, define, this is a Python keyword that indicates that you're defining a new function. Say hello. This is the name of your new function. We've been naming our function main because that's our main part of our program. We're going to change that now. We're actually going to name the functions. So this is define, say hello, and then in the parentheses is any parameters for your function be listed here between the parentheses. If none are required, then it'll be empty. Like with main, we've not required any parameters. So we said define main, open parentheses, close parentheses, right, with nothing in there. And then you got to put that colon at the end to end a define statement. That's kind of like a period in programming here. Define, and then end it with a colon. So it says define, say hello, name, ends it, print hello plus name, and then they want an exclamation point at the end. So to get a better idea how to do this, and check out our quick tutorial. And I'll let you watch this video. We won't watch it. It's 1 minute and 8 seconds. So watch the little video. That's all there's a page 2. Here's basically the whole lesson because page 4 gives us our assignment. So our whole lesson's right here. Making your own functions. Time to pack your own suitcase. So we just read about programmer defined functions on the previous page. So watch just make one in that video. You need to go back and watch that video. And now it's your turn. You can create functions for all sorts of tasks, even to draw a tree with turtle graphics. So as you write your own functions, you're going to identify the code you want to put in the function. What does this function need to do? Right? Is there an action or a set of actions you could chunk into a function? You could define the function, give it a name. These are verbs like print or calculate total or whatever your function's designed to do. They should relate to the action the function will perform. Use the define statement, DEF, to define your new function name. Define, say hello, no parameters needed, colon. Determine your parameters. If your function needs specific values to work, include a list of variable names or parameters between the parentheses. If the function does not require any values to be passed to it, it'll be empty. So like define, say hello, name. In this case, name was already defined ahead of this function. So I need to pull it into this function from the previous function. So let's try your hand at creating some function. So let's look at this one it has here. Let's see if I can get more of a screen. Can I do full screen or something on here? I want to make sure there. I'll make it a little smaller. Just make sure we can see all of it. Follow the instructions on each slide. Complete each activity. This is where you learn how to use this. You need to go through these 7 slides, and we'll do some here as a class. So here's our instructions. Writing user-defined functions, all in main. So read the code, try to predict the output, then run the program, and look at it and see if that's what you guessed it would be. And then select next. All right, so let's look at it. Writing functions, hashtag writing functions. Import turtle. So this is their main, define main. Dally equals turtle.turtle. Dally speed of 10. Okay, hashtag draw tree, hashtag move to position. See, they give, this is just comments that let us know what this little section does. Move to position. Dally set position. So this tells it where to start. See, it hadn't even told us about this function that runs in here. This one of the things it can do. We learned this by going through these programs. So this sets the position of turtle. See, they put a comment after the code. So this code here, set position at 0, -20. And then turn left 90. Right? Remember how the left 90. Draw trunk. So it says choose the color brown, go forward 60. The next comment says it's going to draw leaves. So long green, turn right 90, and make a circle 45. So that's how long the circle is going to be here. Now it tells us it's going to draw a flower. So we've got to move to the right position. So pin up. So here's something we're learning too. This is new, pin up, which means when you move to this new position, don't draw a line from where you are now to where it goes. It's saying pin up. So stop drawing change to this position, 20, negative 20, turn left, and now put your pen back down on the screen. Now start drawing again. So these are some new things that if you don't go through this code, you totally miss that. You don't know how to do that. You need to go through all of these, do what it says, run the programs, go through next, experiment with it. Now it draws the stem. Dark green goes forward 25. That's the length of the stem. Now it tells us it's going to draw the petals. So it chooses hot pink, turns right, makes a circle of 10, and that's the end of the function. Define main, main's over. So when we run it, we expect, because they gave us real good comments in the program, that it's going to move to a position, it's going to draw the trunk and the leaves, and then it's going to move to a different position, and it's going to draw the stem and the petals of a flower by the tree. So let's run it and look at it. Oh, there's our tree. See, it made the stem and then made the circle of 45 pixel radius, and then it moved. When it made the circle, it moved from there to here, but it took the pin up, so it didn't draw a line to connect those. Let's play with that. If we take that out, or if we just put a hashtag in front of it to where it's comment now, so it'll ignore it. Now it's just a comment. We'll see how that changes, and we can watch that happen. So run the program again. See, now it made a green line from where the circle ended to where the flower stem started, because we took out take your pen up and put your pen back down. So that's how you can move positions without drawing. So if we take that back out, now it's code again, so it does not draw between there. That's how you learn what these things do. If we get rid of that code, just make it a comment, see what happens. All right, let's go to the next. Now it says main is growing longer. So read the code and then select run program and then edit the program to draw a second flower. And they want it to be an orange flower, and they want it in this position, 48, negative 10. So imports turtle, defines their main, turtle.turtle, speed of 10, draw a tree, move to this position. All right, turn left 90, draw the trunk, draw the leaves, and then move to a different position with pin up, pin down, draw the stem, draw the rest. So this is the same code we just have. We expect the same thing when we run the program. Okay, that's the same thing. But now it wants us to add another flower in this new position. So we can take the draw a flower code and copy that, because we want to do the same thing. We want to copy that, go down here and paste it. So now it draws a flower here. Right now it's drawing the exact same flower, but we're going to tell it to take the pen up and move to the position 48, negative 10. Okay, so that's the position they want the second flower in. Turn left, make the stem. The stem we still want to be dark green, but we want the color of the second flower to be orange. So let's take out hot pink, make an orange flower. All right, let's back that up to where that is. We're gonna say a second flower. Let's see, draw a second flower. And it ends our main right there. So, all right. So now that we've got that, let's run our program and see if we got the second flower like they wanted it. First flower, second flower. There it is, and it's orange. See, it says to draw a second flower. In case you mess it up, it gives you some information here. You can copy the code under draw a flower. That's what we did. We copied it, and we just changed the color and position. So now the program's getting longer and longer. We're drawing a tree, drawing a flower, drawing a second flower. It's getting longer and longer. If you want to add more flowers, if we wanted 5, 6, 7, 8 flowers, the code would be getting longer and longer. But the code is almost exactly the same. So it'd be nice to reuse it. So let's go to the next slide. Let's read this code, try to predict the output. Draw a tree, trunk, leaves. Now here's a new function. Define, draw flower, and T. See, T is our turtle. T is our turtle. Or T is our function up here. T dot set position, so it's T dot left. So we're going to say, all right, we're going to start a new function. Define draw flower. Take our pen up, move to the new position, sets the position of the new, of where turtle's going to draw at, stem and petals. Then down here, so we've got our two functions. Now we're going to define our main, right? This function up here was called draw tree. This function was called draw flower. Now we're going to go here and say, define our main function, turtle.turtle, speed of 10, draw tree, dally, because that's what they're naming it right there, because we haven't defined dally. Draw tree, draw flower. Draw flower is our second function. All right, and draw tree is our first function. So let's see what happens when we do it. We're back to the original thing. See the difference? There's three functions defined: draw tree, draw flower, and main. The main function is now much shorter, right? It just says, okay, we've defined these functions above. Now just run them. The turtle dally is defined right there. Dally equals turtle.turtle. And then draw tree and draw flower functions are called. And when they're called, Python will jump to those functions and execute the code within them. And when the end of the function is reached, it returns to the main and keeps going. So it does this one, which says draw tree, dally, it goes up there and it draws the tree. And then it comes back here. And the next thing it sees is draw flower. So it goes up to that function and draws the flower. So let's go here. Look at the next one. We define the draw tree function, right? Just like it was. We do define the draw flower function. It's like it was. Now, this is exactly like we just had. Just let's explore some common errors. See, this helps you with debugging walks you through some errors. Try deleting keywords and symbols like define and the colon. Like if we didn't have the colon after define flower and we run it, it says bad input of line 20. We looked at it like, what? It says define, and I named it, and I used the parameter, but it gave me an error because I forgot to put the colon on there. Put the colon on there. Now it's happy again. The error goes away. Delete the T in the parentheses of the draw flower function. Let's try that. And let's see where the error shows up. Oh, it drew this, no problem. Drew the tree. But then when it gets draw flower, type error, draw flower takes exactly 0 arguments. But there's one given on line 44. See, line 44 says dally, which is, here's the argument, turtle.turtle. But we did not add the argument inside there. We put the T back. Now it's happy again. Draws our flower. All right, be sure to fix the error before trying another one. Yeah, don't combine a bunch of errors because you want to understand what the error is doing. Let's see, what if we take color off leaves? I mean, the T dot. Just wondering what that will do. Oh, color is not defined on line 16. T dot, got to have that T dot. And now it's fixed again. So fix the errors before you try another one. Define draw tree. Let's see if we took the T out of here and out of here and took dally out of here. See what happens. T is not defined on line 8. So it gets here. It doesn't know what to do because it's got this argument T, but we didn't tell it to use a T anywhere. So we got to put that argument back in there. T. So this is the different functions it uses, the different process it uses with that T argument. So we've got to put the T back in there, or it gives us that problem. And then we're going to put dally back in there. So make sure we fixed it. Yep, we fixed it. Everything's there. All right. Let's look at this. Import turtle, draw tree.t, argument of T. There's the trunk, there's the leaves. Now we've got define draw flower T comma C. We've got 2 arguments. T is the turtle, C is the color. So this sets the position just like before. This does T.color. Now see, I haven't seen me use C. Oh, down here in our petals, T color, and C is just an argument here. We didn't actually give the color here for the petals. Before that said orange or whatever color we wanted that to be. So here in their define main, they've added the color down here, T.C, the T comma C. So T is Dali. We want this to be the turtle.turtle. And we're defining it down here. So when we run it, we're going to have a red flower right there. And now, since we've done it this way, if we want, I wonder what happens if we just add a second flower underneath it. Draw flower, Dali, comma, purple. Now here's the thing though. We haven't told it to do a new position. It's probably going to draw it right over the top of the old one because nowhere do we have a variable there to move it. But let's see. It did. It drew the second flower right on top of the first flower. So this line, somehow we need a parameter in there to be able to move our flower. But this is cool. So we've changed it down to our main function where we can choose the color. All right, so now let's look at what they've done in the next one here, number 6. Draw a trunk, draw leaves. Now we've added 4 parameters on the flower. T is the turtle, C is the color. So moves to position X, Y. It didn't give a position. It left that as one of the variables here, one of the parameters, X and Y's parameters. So set the position X and Y. Move left, do dark green, and the petals will be the parameter C, whatever C is defined as. So we get down here to our main function. Now it says make a red flower at this position, 55, -20. Make a gold flower at -20, -25. So if we run the program, there it is, and it moved over here. So now we can take that, we've got the extra parameters, we can add a third flower. Just using the same, I'm going to change my indentation to be consistent. So let's make a blue flower at -40, -15. How about that? Let's try that. Run program. There it is. There's our blue flower. And we can just sit there and continue to add flowers by adding just one line at a time. See how this got so much simpler? Before, if we want another flower, we had to take all of this code here and copy it to add another flower. Now that we've defined our own function, here's our own function called draw flower, and we've given it the parameters that we can change for each flower. Now to add flowers, it just takes one line. We just tell it the new parameters. The turtle.turtle named Dali, the color, and the position. Left and right, -40 and -15. So let's add another one just for the fun of it. Draw flower. Oh, got to capitalize. If I don't capitalize this flower, it will give me an error. In fact, let's do that just to show that. Because to the computer, a capital F and a lowercase f are 2 totally different things. It doesn't read it and say, oh, that's just an F. It looks at the actual computer code and says that's not the same thing. Let's see, what shall we do on this one? Let's make dark green. We'll do this one over at 75 and -10. We'll put that one higher on the screen. Let's run the program. Makes that flower, makes that flower, makes that flower. Runs into an error. Draw flower is not defined. And you're like, wait a minute, draw flower is defined. No, it's not, because we did not put a capital F. You have to use, if you use capitals, every time you refer to that same variable or that same function or whatever you're referring to, you have to use a capital if you used it the first time. So now it should run and draw our 4th flower. There it is. There's our 4th flower with the dark green. So see how defining functions can be very useful and save a lot of time, because you just give it the parameters that you need to change every time you use it. And then use those parameters down here. Save a lot of programming code. If I say, make me a field of 5 trees and 10 flowers, you don't want to have to write code that goes on page after page after page after page. Just write the one function that draws a tree, one function draws a flower, and then you just need one line per tree and per flower. All right, here's the last example they have. Modify the draw tree function so the color and position can be passed as parameters. Okay. So yeah, with the tree, we haven't done that. We did it with the flower. So let's say color X and Y, right? And so the position would be X and Y. Let's just run it like that and see what it does. Oh, it says draw tree takes 4 arguments, and we didn't put any down here on line 53. Oh, let's see, draw tree Dali dot color dot space that. Okay, now we did the parameters. Let's see what happens now. C is not defined on line 53. See, I put it up here in the parameters. I did this on purpose. I put it in the parameters, but nowhere did I put a C in my function. So instead of the color brown, I'd want to make that my C. The color will be C. Right? So down here, when I tell it to use the function C, I need to define, oh, I'm sorry. Yeah, that's in draw tree. Draw tree C. What happens here? It says C is not defined. It's because I need to tell it the color. Let's make our tree orange because it's getting to be that time of year. All the leaves, actually, our leaves are falling off now. So what happens now if I do that? I gave it orange. Now it says X is not defined because I need to give it a position. Need to give it a position. Let's give it a position of, looking at what we got there. Let's do 0. And let's do 0 there. See where that draws that. Now we run the program. There it is, 0, 0. So we made, oh, that was our stem, wasn't it? Did I put that in the stem? I did, the trunk. I made the trunk C. Let's make our trunk brown. Make our leaves the C. So where I put my parameter, you've got to pay attention to that. So now it's got a brown trunk and draws 4 flowers because when they get down to the define here, they put 4 different flowers in their main function. So it says modify the tree function, so the color position, update the program to draw at least 3 trees. Okay, so let's take this line that draws trees, and we can put it after the flowers, whatever order you want to draw them in. Need to make sure my indentation is proper here. Oops. All right, so let's make this red, and this one still, this is an evergreen, so it's still green. And we're going to move this to position, let's see, the first one's left and right. So this was at 70. So let's make our tree over at 90. We'll leave it at 0. And this is at negative 50. So let's make this one negative 70. And you can play around with that. If the tree is not where you want it, change those numbers. Let's run the program. There we go. So we've got our red tree over here at 90. See if we move, and we don't know which number changes anything. Make that 120 and see what happens to the tree. Something to my tree if I change it to 120. Well, that moves it farther to the right. Okay. So maybe I'm happy with that. If I change this to negative 20, what happens to my tree? That's how you figure that out. Change it and see what happens. See, it moved down here. It was at 0 up where these are. But I moved it to negative 20, so it moved down there. If I make that a positive 20, it should move up above the other trees now, right? See, now it's higher than the other trees. If you're not sure what these do, just change it and see where it moves. All right, just change those numbers and you can see where it moves. You could do that with the flowers too. We can move that flower up here. We want this to go up. Let's change that to a positive 18. Now this orange flower should be higher. I mean, this last flower right here be higher than the pink one. It's higher now. So you just play with those things. Add more flowers to the picture. Refer to the previous slides as needed, run program. So we added more trees. Let's just go ahead and add more flowers too. So I'll let you play around with that. But that's it, slide 7 to 7. So let's go to the next page and see what our assignment is. Assignment template. This assignment is 3 parts. Write a program to draw a picture by defining functions, use Turtle Graphics. And here's the guidelines. Give your artwork a name, right? So print the name to the output. Some of y'all missed that last time we drew something. So you're going to give it a name and then print that name in your output. Then I want you to draw a picture using Turtle. You can decide what you want to draw. It doesn't have to be trees and flowers. You can draw a house, a car, a face, a robot, whatever. Now you know how to pick the pen up and put the pen back down. You know how to move left and right, up and down by changing those parameter numbers. You can draw straight lines. You can draw circles. So you can attempt to make something fancy. Use at least one color apart from black, right? So don't make the whole picture black. Choose a color. So the picture should include some color. Now here's where you put your pseudocode. Remember, we're going to copy this. In fact, I'll copy this and put it in Google Classroom. So it'll make you a copy of this page. Put your pseudocode here. That's just your plan. That's just written in English. That's not where you're writing define main parentheses, parentheses, colon. No, that's actual code. Pseudocode is like define main function, define tree function, define flower function. You know, that's what we pseudocode. I'm going to define my flower function, and then I'm going to have it set, you know, parameters for color, parameter for, you know, whatever. So then code your program, and here's the guidelines. Use Python, of course. Make sure you have your comments, the heading that has your name, date, and short description of program. Need that every time. So if I just had these printouts of your programs, I'd pick it up and know exactly whose program I'm holding in my hand because it would have your name on it. And make sure you indent properly and use some white space, you know, space things out so we can see it easily, and use meaningful variable names. So there's not a whole lot of requirements here for the code. They're giving you a lot of freedom on there. So here's some really fancy drawings that they're showing as examples. Like this one, they name Home Sweet Home. So they printed at the bottom, Home Sweet Home. They started out building their house, and then they added a tree, and added a bunch of flowers. They even put a sun up there. So again, they've messed this up. It says insert your pseudocode here. No, our pseudocode is up here. Our actual code goes down here. So I'll change that when I put it. And then, of course, our post-mortem review where you answer the 4 questions about your program. So there's what we're doing this week. We're drawing a picture of whatever you like, house, car, face, robot. You can do trees and flowers if you want to, but it can't be exactly the program that was in the assignment, in the lesson. You have to do something different. If I just see you copy the lesson, then you're not getting any points for it. So you've got to write your own. You got to make it different than the example they gave you. And then if you want to know how it's graded, the rubric is right here on how you get points. 10 points is just having your name and date, the comments, you have the indentation correctly, and you're using good variable names. Right? That's worth 10 points. 40 points is on having your code actually reflect the pseudocode. What you said you was doing in the pseudocode, you actually did in the program. That you've defined your main function, you've done your turtle function, and that you have at least 2 programmer-defined functions. You have to have the main function. You have to have at least 2 other functions that you defined, right? So that's part of the 40 points. And you have to print the name of your artwork to the screen. So that's 40 points all wrapped up into there. 30 points on does it run correctly with no errors and produce what it's supposed to. And then 20 points for describing the purpose of the program, explain, you know, the 4 questions at the end. The post-mortem reviews were 20 points. So 20 points there, 30 points there, 40 points there, 10 points there, 100-point assignment. So that rubric's always right there to show you how the assignment is graded. So there's your assignment. There's your rubric. Go back and watch that video. Like I said, it's 1 minute and 8 seconds. That explains some of this. You can go back to those examples that I just went through and try those yourself. And I would encourage you to go back to the examples we went to as a class and try those yourself and change something and see what happens to your program. Change something. Now, once you change something, if it creates an error, fix that before you change something else. So that's how you learn what a line does, or what a variable does, or what changing a number does, is just to go change it and hit run. If you totally mess it up to where now it's done running, you can't fix it, well, just go to a different page and come back and it'll reset it. Right? Get out of the lesson, get back in the lesson, it'll reset it. So you can't really mess anything up there. So fix something, change something if you need to fix it, or you say, oh, I see what that change does. So that way you could experiment with that when you're writing your own. That helps you in learning how to debug by playing with the built-in programs they have. So I encourage that greatly. So, all right, that's all we have this week. That is your assignment, and work on getting any past assignments turned in. If you need to go back and look at those lessons, they have the same little programs in there that you can change things and figure out how the while loop works, or this printing strings work, or whichever of the past lessons you need to work on. The math module has those example programs. You can go in and change things. So get everything turned in. Finals due 2 weeks from today, so we're running out of time. Get your stuff turned in. If you need help with anything, let me know. I'll be happy to explain things one-on-one with you and help you understand when you're trying to write these programs. So if you have errors you can't solve also, you can copy and paste and email it to me and say, Mr. Brock, I can't find my error. I don't know how to fix this. And I'll help you figure out what your error is. So, all right, guys, that's all of class for today. I will see you on, oh, this is not a B this week. I need to change that to Mayday. I haven't fixed that for the week. So. All right, I'll see you on Wednesday and or Friday if you need me.